Okay, so let's talk about some key properties of trees. 3 key properties, in fact, of trees. So the first property of a tree is called the single path property. In a tree, there is only one path connecting 2 vertices. Okay. Now I know what you might be saying. Oh, wait a minute. It doesn't mean edge. It means path. You might be saying, there's no edge from B to D. You're right. There isn't an edge that goes directly from B to D, but there is a path. And what the single path property says is that there's only one path connecting any 2 vertices. So in other words, to get from B to D, there's only one way to go. You have to go to A, then H, then D. There's no other way to get from B to D. You can't go to G, then C, then to D. If you could, there would be a circuit, and then it wouldn't be a tree. Okay? There's only one way to get from B to C. You have to go to G, then to C. So that's what the single path property states. There's only one path from a specific vertex to another specific vertex. Okay. The all bridges property. We didn't cover chapter 5 where they specifically talk about bridges, but a bridge in a graph is an edge that if you took it away, the graph would become disconnected. Okay? So it turns out in a tree, if you take away any edge, it's going to be a disconnected graph. So for example, if I took away this edge right here, this graph is no longer a connected graph. C doesn't have an edge going from it to any other vertex in the graph. So every edge in a tree is a bridge. In other words, every edge, if you took away any edge in the graph, it would go from being a connected graph to a disconnected graph. That's all that means. So in other words, every edge is really important. If you took it away, it would no longer be a connected graph, which means it wouldn't be a network, which means it wouldn't be a tree. Okay. The n minus 1 edges property. A tree with n vertices always has n minus 1 edges. So we can look. How many vertices are here? 1, 2, 3, 4, 5, 6, 7, 8. That means it has to have 7 edges, and only 7 edges. So without counting the edges here, right now, I can tell you that this has 7 edges. Let's count. There's 1, 2, 3, 4, 5, 6, 7. So that's all the n minus 1 edges property states, is that if you have n vertices, they're going to be n minus 1 edges. Always. Okay. The converse is true too. If you know a network has n minus 1 edges, then it's going to be true. It's going to be true that if you know a network has n minus 1 edges and that it has n vertices, then the network has to be a tree. Right, so those are 3 key properties of trees.